All right, let's talk about data encryption. So when we are talking about data encryption, basically, we are appreciating the fact that if two parties, that's A and B, if these guys want to communicate, right? Let's say A sending to B and B sending to A, there is always a risk of data interception. Yeah, there is always a risk that there is somebody, a third party, who's going to be sitting here and try to tap into this conversation, right? And this, we can just call this person probably a hacker, right? This data transmission, this communication channel can be intercepted by this hacker. So we're calling this data interception. Data interception. So we're saying that this information, this communication is always at risk of data interception, whereby a hacker can tap into this network and try to get the messages or the information that is being communicated between A and B. And this risk is always there because there are always smarter hackers. There's always someone smarter in the room whereby any information can be hacked, right? So with that now, there is the part for us to protect the communication between A and B. That's where data encryption comes into play, whereby A will type in a message, right? A will type in a message and we'll call it what? We'll call it plain text, right? A will type in a message and the message will be in the form of plain text. So plain text basically it's the text that is readable. Plain text is a text that is readable that A is going to be typing. But at the very end of the day, B now needs to be having this information. But during transmission now from this end to B now, we need this plain text to be converted into ciphertext or into scrambled text. So what we are basically talking about now is the part of maybe scrambling data. Okay, let me just put it like this. When we talk about the part now on data encryption, we're saying that plain text that is going to be typed by the sender is going to be converted now, is going to be scrambled into ciphertext. Into ciphertext. By definition, when we talk about ciphertext, we're talking about the part of scrambled text. Scrambled text. So we're saying plain text is always readable, yeah? So this is readable text where we can get meaning out of it. Scrambled text. But ciphertext now is scrambled text. So this is basically what we are calling encryption. The conversion of plain text into ciphertext. That's what encryption is all about. And this conversion now is going to be making use of what are called encryption keys. We can talk of encryption keys or encryption algorithm. So let's just call them encryption keys like this. So encryption keys or encryption algorithms. So if we take plain text, we place it or we apply an encryption key on it or an encryption algorithm, we then obtain what is called ciphertext. So by definition, ciphertext now is just scrambled text that is not readable. Yeah? So let's just give an example real quick. Suppose that we have a text like comps is fun. Comps is fun. This is plain text. This is an example of plain text. I can read this and then I can understand this. So if I want to send this to B as encrypted data, I'll place this now into an encryption algorithm. Whereby this text is going to be converted probably into something like this. Hash, $, exclamation mark, 3, 2 for comps, then is might come through as maybe 1 and asterisk, then fun maybe might come through as 7, U and maybe P, like this. So if you have something like this now, this is no longer understandable. Why? Because we have converted this plain text into what is called now ciphertext. Plain text, readable text into scrambled text. So when you're transmitting this type of information now, we are no longer scared about this person now who might come through to tap into this conversation. Why? Because even if they get the message, they're going to be getting it as ciphertext, which is not readable. You get the point, which is not readable. So when we have plain text having been converted into ciphertext, we can safely say that we have safely encrypted our data, right? So a plain definition that we talked about is on the part of encryption. We said encryption. Encryption, we said, is the conversion of plain text. Of plain text into ciphertext. Into ciphertext. By the use of encryption keys. Right? Or encryption algorithm, basically. That's basically what we have as far as encryption is concerned. We want, check this part, encryption does not avoid or does not stop our information from getting hacked. We can still be hacked. Data interception can still occur. A third party can always tap into our communication. But when they obtain the data now, the data that they're going to be obtaining is going to be in the form of ciphertext, which is not readable, which is not understandable. The only person who can understand this information is the one with the decryption keys now. Yeah? So encryption always works hand in hand with decryption. When we encrypt data, we need to decrypt the data again. So if you need to understand this ciphertext, you need to be having a decryption key, the key that you're supposed to be using to convert this back to plain text. So decryption by definition is just the opposite of encryption. It is the conversion now, but of ciphertext back to plain text with the use of decryption keys. Yeah? So we are using a decryption key to convert this ciphertext back to its plain text. That's basically what is happening as far as decryption is concerned. So one key point is that encryption does not stop data interception from occurring, but it prevents the third part or unauthorized participants from understanding or getting the meaning of the data that is being transmitted. You get the point? You can hack us, but you'll never be able to understand what we're talking about. That's basically what we're talking about. Yeah? So let's now appreciate maybe the two types of encryption methods that we're going to be having. Yeah? Let's appreciate the two types of encryption that you're going to be having. Encryption now, can always come through in either as symmetric encryption, or it can come through as asymmetric encryption. Yeah. So talk about symmetric encryption now. This is when the participants, the sender and the receiver, they are using the same single secret key. Yeah. They're using the same single secret key to encrypt and to decrypt. They're using this to encrypt. Okay, let me just remove this. To encrypt and also to decrypt. You get the point? The sender and the receiver, they're using the same key to encrypt their messages and to decrypt those messages. But when you're talking now about asymmetric encryption now, we're talking about the part of making use of two pair of matching keys. We're using a pair, okay, let's just have it like this, a pair of matching keys. Right? So if it's a pair, one is going to be used to encrypt, the other one is going to be used to decrypt. The second one is going to be used to decrypt. Right? So we'll talk about these in a second. We'll talk about these type of keys in detail in a second. But basically know this part that encryption is going to be coming through with two types. There is symmetric encryption, whereby we're using the same single secret key to encrypt and to decrypt. Then, when we're talking about the part of asymmetric encryption, we're talking about the part where we are saying that there is a pair of matching keys that's going to be used. One is going to be used to encrypt, the other one is going to be used to decrypt. That's basically what we have is the two types of encryption. Yeah? So, let's go ahead and actually have maybe a session where we talk about let's talk about the part maybe on symmetric encryption in detail, yeah? Let's talk about symmetric encryption. Oh, come on, really? Yeah. So, just for an example, let's use our key as this. Let's say our plain text is going to be coming through like this. Plain text, we have A, B, C, D, and E. Yeah? Then the corresponding ciphertext now for these letters probably is going to be like A is going to be 1, B is going to be F, C is going to be coming through as Z, then D is going to be coming through as a hash, then E is going to be coming through probably as a 3, right? So this is a key that probably we are going to be using to do our encryption. Is the same, our encryption and our decryption. So this is our key. Yeah? So if this is like this, we're talking about the part that if a message, a plain text message that's going to be written, maybe it's going to be coming through like, is a plain message is going to be coming through like bed, like this. Let's say it's a bed card like this. Right? So if we have this as plain text, when it's going to be transmitted, we're going to be taking this first into the encryption algorithm, and it's going to be transmitted now like this. B is going to be F. A is 1. D is hash. So bed is going to be coming through as F1 hash. C is Z. A is 1. D is hash. So at the end of the day, this is what is going to be transmitted. Right? So plain text bed card has been transmitted now to be F1 hash, Z1 hash. So at the end of the day, if we transmit this now, this is not going to be understood by the hacker or anyone who intercepts the data unless they have this key again, where they're going to be coming through now to decrypt the data now. So this is the encryption process. The decryption process now is going to be coming through to be doing the very much a reverse of what we did first. So we're going to be checking again. We're going to be using the same single key to encrypt and to decrypt. F in ciphertext, converting it back is going to be B. 1 converting it back is going to be A. Hash converting it back is going to be D. C converting it back, Z converting it back is going to be C. 1 converting it back is going to be A. Then D converting it, hash converting it back is going to be D. So this is now the decryption. We are still using the same key. That's why we're calling it symmetric. We're using the same single key to encrypt and also to decrypt. That's basically what symmetric is all about. So you see now, there is a problem that actually arises with this. There's a problem that rises with symmetric encryption. The problem, if you have guessed it, it's the part that if A and B, if they're actually communicating, right, they first have to share the same single key that they're actually going to be having, they're going to be using in their communication. A will have the same key as B. So during the transmission of this key now, if it's going to be transmitted online, if a hacker gets hold of this key, then that hacker can actually be able to understand the information that is being transmitted by A and B. So if we're going to be sending this key over the internet, and if it gets hacked, then the person we have hacked, it can now be able to understand or to decrypt the information that is being transmitted between A and B. So there's always a risk of the part that the same single key that is being used to encrypt and to decrypt can get hacked. Then we are now stuck because the hacker can now understand the information that we are probably sending to each other. That's what the reason as far as symmetric encryption is concerned. But otherwise, if we have this information or this key having been sent to B without getting hacked, then that's a plus to us because A and B can communicate with nobody being able to understand exactly what they are actually sharing. Yeah. But the other one of the ways now that we can actually try to avoid this type of an error is by making use of asymmetric encryption now. right? Asymmetric encryption. When we're talking about asymmetric encryption, we're talking about the part that A and B are going to be having a pair of matching keys. Yeah? So A is going to be having one key that is called a private key. A private key. Then also B. Then A again is going to be having again another key that is called the public key. Oh, by the way, asymmetric encryption can also be called public key encryption. Public key encryption. Yeah. So on top about the part now on a private key, we are saying that this is a key that is not shared. Let's start by that part. It's not shared to anybody, but the public key is going to be shared. Yeah. Is the key that's going to be used, that's going to be shared by the participants. So A is going to be having private key and a public key, a matching public key. B also is going to be having his own again. B is going to be coming through again to be having his two pair of keys again. B is going to be having again his private key and also a public key. Check this part now. So, if A wants to communicate to B, the very first thing that's supposed to be done is A will send his public key to B. Right? Let's say that B wants to send a message to A. Let's have it like this. B wants to send encrypted messages to A. This is what's going to be happening. B is going to be first requesting for A's public key. So A will share his public key with B. So B is going to be having now A's public key. That's what's going to be happening. So if B now has A's public key, A is going to be remaining again with his private key. Because private keys are not shared. Right? So when B wants to send a message to A now, so this A's key can be sent even over the internet, which means there's the risk of it getting hacked. You get the point? But check this part now, why that does not really matter if it's hacked or not. So B is going to be writing a message, let's say a bed deck like what we actually, bed card like what we had, bed card, message in plain text here. Then B is going to be using A's public key to encrypt this information. So take this information to A using A's public key. Then we're going to be having now F1 hash. Then let's say 3, I don't know what we had on top there, but let's just say it's going to be coming through as asterisks. It's going to be 1 again here. 1 hash like this. At the very end of the day, if this is what we're going to be getting as ciphertext, B will send now this ciphertext now to A. When A receives, which means this information can also be hacked, but check this part. After A receives this ciphertext now, A can now decrypt the ciphertext using his private key, because the private key was not shared and it's a pair of matching keys, remember? So P, public key, is going to be used to encrypt. A's public key is going to be used to encrypt. B will use A's public key to encrypt the data. Then B will use his matching private. Then A will use his matching private key to decrypt the information that has been sent by B after having encrypted by his public key. So what A's public key encrypts is going to be only decrypted by A's private key. So we are saying now, if the hacker gets to get hold of this information, they still do not have A's private key. So at the end of the day, they cannot understand this ciphertext. What is encrypted by A's public can only be decrypted by A's private. What is encrypted by B's public can only be decrypted by B's private. That's the reason of actually keeping this now a little bit secure. Why? We are saying that we're going to be keeping the part on We're going to be keeping the private key secure. Why? Because we're going to be using this to decrypt any information that you're going to be receiving that has been encrypted by these mails, that has been encrypted by the matching public key by anybody who's going to be sending. So let's talk about that one more time. A wants to talk to B. So B will request for A's public key. So B will write a message now in plain text like bed card. At the end of the day, B will then encrypt this message using A's public key. We now have ciphertext now. This ciphertext is going to be sent now to A. A will receive the ciphertext and will decrypt the ciphertext using his private key, which he did not share with anybody. That's how symmetric encryption is going to be coming through to be a little bit better. That's how asymmetric encryption is going to be coming through to be a little bit better. So yeah, that's pretty much as far as encryption is concerned. Key points: encryption is not about stopping us from getting hacked. We can always get hacked even after having encrypted the data. Encryption is just the conversion of plain text into ciphertext using an encryption key. The reason why we are doing this is because any third party who wants to hack the information or wants to intercept the information can get hold of the information, but they cannot fully understand exactly what is being said or what is being meant by the data. The only person who can understand this information is the one with the decryption key. So on symmetric encryption, we are using the same single shared secret key to encrypt and to decrypt. But then on asymmetric encryption, we are using a pair of keys. We have the public key and the private key. The public key is going to be used to encrypt what is going to be decrypted by the matching private key. That's pretty much what we have. I hope you understood, and that's what we have as far as encryption is concerned.